Greetings, folks. Welcome. One of the most common applications of statistical inference is to use information from a sample to estimate a population mean value. When we do this, we're actually estimating a confidence interval of that population mean. So here you see the formula. Mu represents the population mean. That's ultimately what you're trying to estimate. Equals x bar, that's the sample mean. So this is something you can calculate. So you go out and you collect data on a random sample of observations, and you can calculate the mean value. And then you put the margin of error around that sample mean value. So that's the rest of the formula, which is plus or minus t subscript alpha divided by 2. This is a t statistic based on the confidence level that you set as a researcher. You multiply this by the standard error of the sampling distribution, and that is S, which is the standard deviation of the sample, divided by the square root of n, which is the sample size. So the confidence level is something you set as a researcher, or maybe if you're working for a research team, maybe your boss or somebody else on the team sets a confidence level. If you're doing a 99% confidence level, that means that you're 99% certain that the confidence interval will include the true population mean. Let's say you do a 90% confidence level, then you're only 90% certain that the confidence interval that you calculate will include the true population mean. Here are the steps that you follow to find the t-value that you'd use to calculate your margin of error. First, you set your confidence level. Again, it could be 99%, 95%, 90%, whatever. You take 1 minus a confidence level. That gives you the value for alpha. So let's say you do a 99% confidence interval. 1 minus 99% would be 1%. Then you calculate alpha divided by 2. So whatever alpha might be, if it's 1%, then alpha divided by 2 is 0.5%. Or if your confidence level is 95%, that makes alpha 5%. Then your alpha divided by 2 would be 2.5%. Next, you find the t-score that corresponds with alpha divided by 2. Of course, you're using n minus 1 degrees of freedom because your t-distribution looks different depending on the degrees of freedom. So here's an example. Let's say you want to calculate a 95% confidence interval for the average age of people who visit Disney World. That's why I'm wearing my Mickey sweatshirt here. Mickey wants to know the average age of people who visit him at Disney World. You take a random sample of 60 visitors to Disney World. Oh my God, now the dog's all excited. The dog heard me doing the Mickey Mouse voice, and now the dog wants to get in on the fun. Okay. She always has to get the last word. Okay, so you take a random... Oh my God, I keep talking and she keeps barking. Okay, so you take a random sample of 60 visitors to Disney World and find a sample average of 39 years old with a standard deviation of 10. Again, this is information you could collect. You could go into Disney World. You might get in trouble with the people that run Disney World. You might get in trouble with Mickey Mouse. But you could ask 60 visitors, a random sample of 60 visitors to Disney World, ask how old they are. Let's say your sample average is 39 years with a standard deviation of 10. So if you're doing a 95% confidence level with a sample of 60 observations, the alpha is 0.05. That's 1 minus 0.95. Your alpha divided by 2 is 2.5%, or 0.025. So we have to find the t-score that corresponds with 2.5% with 59 degrees of freedom. So here's our trusty t-table. You go down to 59 degrees of freedom and across to 2.5% in the upper tail, and you get a t-value of 2.001. So we can actually put this on our t-distribution. So here's a t-distribution with 59 degrees of freedom. We're showing 95% of the distribution in the middle because, again, we're trying to capture a 95% confidence interval. So we have 2.5% in each tail, which is why we used 2.5% when we looked up the value in the t-table. So on the right side of the distribution, it's 2.001. On the left side of the distribution, it's minus 2.001. So now we have the values, everything that we need to calculate the confidence interval for the population mean. So we want to know the average age of all visitors to Disney World. Our sample mean was 39 years old. Our t-statistic is 2.001. That's because we have a 95% confidence interval. If we'd selected a 99% or a 90% confidence interval, that t-statistic would be different. You multiply that by the standard error of the sampling distribution, which is the standard deviation of the sample, which is 10, divided by the square root of the sample size, which is 60. This gives us a confidence interval of 39 plus or minus 2.6 years of age. So what we can say here is that our confidence interval goes from 36.4 to 41.6 years. So we are 95% confident that the average age of Disney World visitors is between 36.4 and 41.6 years of age. And because we did this calculations for Mickey, he's got one thing to say to all of us. Thank you, pal.